What we're going to look at in this video is recognising and determining the equation of quadratics from their given graphs. A quadratic is something in the form that has a term involving squared, and that would be the highest power. So it could be x squared plus 4x plus 3, x squared plus 2, minus x squared, minus 6x squared plus 4, as long as the highest power is an x squared. And we've been working with quadratics so far. We've been solving quadratic equations, we've been factorising quadratics, but now we're going to think about what they look like. If we were to graph this expression or this equation here, we've got y equals x squared. So if you'd like, we could do a table of values. Let's say minus 2, minus 1, 0, 1, 2. So to find out what y is, I need to square x. So here I'm going to do minus 2 squared. Minus 2 times minus 2 is 4. Minus 1 times minus 1, 1. 0, 1, 4. And if we were to this, we would have something that looks something like this. So we've got 0, 0, 1, 1, minus 1, minus 1, 2, 4, minus 2, 4. But notice how this time it's curved. And this shape, when we have a squared term as our highest power, this shape is known as a parabola. A few things to notice here is that the parabola is like a U shape. How I teach this, how I generally think about it, is that it's smiling. It's a happy parabola. It's a happy parabola because the term in front of the x squared, the thing in front of this term here, is positive. So it could be x squared, 4x squared, 7x squared, 100x squared. As long as it's not negative, you will have a parabola that is roughly in this form, but it's going to be happy. It's going to be a happy parabola. One thing to note about parabolas is that they are exactly symmetrical. And they are symmetrical about the turning point of the parabola. We could follow through a similar process and we could plot y equals minus x squared. So once again, this is a parabola. It's symmetrical about the maximum turning point this time. But notice how this time it's like an N shape. It looks like kind of like a sad face, like a sad mouth. How I refer to this is I refer to this as a sad parabola. And it's a sad parabola because the term in front of the squared is negative. So if it's negative, we are going to have something that is sloping down the way. It's going to be like an N. If it's positive, we're going to have a happy parabola. So happy parabola, smiling, sad parabola, frowning. Okay, here we're just going to look at a few transformations that can happen to parabolas vertically and horizontally. Here we've got a regular y equals x squared graph. Thing to note about the y equals x squared, it passes through the origin and it's symmetrical about the y-axis. But let's imagine that I wanted to graph y equals x squared plus 2. Let's see what that would look like. If we have a look at the graph now, y equals x squared plus 2, which could be obtained from doing a table of values, we notice that here is a regular y equals x squared, and here is y equals x squared plus 2. So it's still symmetrical here. This is like the line of symmetry. But notice that the turning point, the minimum turning point of this parabola, it went up 2 places. So the turning point here would be 0, 0. It would now be 0, 2. It's went up 2. And that corresponds to the plus 2 at the end. If we were to look at, for example, y equals x squared take away 5, we find that once again it is symmetrical here, but instead of the turning point being at 0, 0, It has went down this 5 steps. So the turning point is now 0 minus 5. One thing to note, these are all happy parabolas because the term in front of the x squared is positive. Okay, so if we've got a constant at the end of our expression, if the constant is positive, we'll move up that number of steps. If the constant is negative, we'll move down the required number of steps. You would be expected from a question to be able to identify these equations here, like these ones here. So if you were given a graph that looks like this, but you were not told the equation, and it was symmetrical along the y-axis, all you would need to do is count down the steps 1, 2, 3, 4, 5, so it would be y equals x squared take away 5. Similarly, if it was 1 up 2, it would be y equals x squared plus 2. Just one more wee thing to note. If we were given this graph here and we were asked to identify it, first thing we should be looking for is, like, what direction is it going? Is it a happy parabola or is it a sad parabola? And we can see here that it's like a sad mouth, so it's going to be a sad parabola. So we can start off by saying y equals minus x squared. We then need to look, or we need to think how we could compare that to the normal y equals minus x squared. The usual y equals minus x squared would have a turning point here, and it would like slope like this. However, here we've got minus x squared, but we've moved up 1, 2, 3. So what we need to do is say the equation is going to be y equals minus x squared plus 3. Okay, let's consider this question here. We want to write this parabola, we want to write this equation in the form y equals ax squared plus b. This one's slightly different though. We cannot say that it's just simply going to be y equals x squared take away 2, because we've moved down 2 steps here. We cannot say that. This would be incorrect. This is incorrect because we have been given some additional information. And because we've been given this additional information, it means that the term in front of the x squared, the coefficient of x squared, is not going to be 1. So we need to find out what that a will be. So if I just take this across to the next page, just going to take a wee note first. This is my x coordinate, this is my y coordinate. So I've got the equation in the form y equals ax squared plus b. If we recall, this part that's tagged on at the end, this determines if we move the graph up the way or if we move the graph down the way. And if we compare back to the previous page, it had moved down 2. That part does not change because the graph has indeed moved down 2. The graph gave us 2 coordinates, or it gave us one coordinate. It gave us a coordinate 1, 1. And we want to find out what this unknown is here. We want to find out what a is. So what we're going to do is we're going to substitute the x and the y coordinates into our equation. So y, so that is 1. So 1 equals a times 1 squared take away 2. So 1 equals, 1 squared is 1. So 1 times a is a. Take away 2. I want to find out what a is. I'm going to balance my equation by adding 2 to both sides. I'm going to have 3 equal to a. So a equals 3. So I've now found out my value for a. So all I need to do now is substitute it into here for my final answer. So my final answer would be y equals 3 x squared take away 2. If you are given an additional point on your parabola, you would tend to need to substitute in. If you're not, and it's just like a vertical or horizontal shift, you can just take a wee note of that straight away. One thing to note here, if we think back to a parabola, it was a happy parabola. So that means that we should expect this number here to be positive, which it is. If we got a negative number here, that would be incorrect. Thank you very much.